This conference will now be recorded.
Was founded by 1999 by a group of professionals with technical and domain expertise as exceeding 18 plus years of experience. And other than that, like it is the Micronet ID company is one of the biggest professional service provider in the United States. And the other one, okay, this Docker introduction is hosting by Micronet as well. So at the end of the section, we're going to share some of the links about the feedbacks. You can provide the feedbacks on the web, Facebook, LinkedIn, and also you can post it in the meetup as well. We're going to share this information as well, right? So let me start the section. So this completely hosted by Micronet. So I'm going to start this session. Hey, hands-on Docker introduction by Sai Krishna Mandava. Okay, let me give you a brief introduction about me. So myself, Sai Krishna. So I'm working for a DevOps and cloud automation architect. I have 7+ years of experience in working with the multi-cloud technologies, and not only that, I do have experience working with the orchestration of the Kubernetes, Docker, OpenShift, all those kind of things. Right. Today I'm going to talk about complete introduction about a Docker, and we are going to see some of the examples how to write the Docker files, how we are going to troubleshoot a minor kind of issues that you are going to face during your section, right? So that's what we are going to talk about, right? Let me give me the brief expectations on this one as well. Yeah, this is expectations. So this is basically an introduction to Docker to intend those who have no hands-on experience with Docker. So if you guys already have a good experience working with a Docker, or like if you were already familiar with the Docker and you have working with the prior if you have prior experience, you are not going to much get on the sections, but you will get if you are completely new, and I can say this is a good start point for entire your career as well, right? So what is Docker? Basically, Docker is a open source platform for building, shipping, running application using Docker container virtualization technology, right? So this Docker platform used to containerize our softwares using which can be easily build your application and package them and share along with your application dependencies and share across with the multiple persons, right? So who can what kind of things it's going to simplify if you work for a DevOps teams, right? It is the best practice for the developers and to create your applications and deploy to the respective environments, and it also useful for the system admins who like to do the lot of automation. Basically, as a system admin, he is going to install a lot of softwares, right, such as the application dependencies. He's going to install some of the configuration dependencies, right? So he's going to face a lot of issues while it's configuring the application installations or the dependency configuration, right? So these kind of things, this by using the Docker, these kind of things will be very simplified for the system admins and the developers as well. Right? Why we need Docker? So if you go back couple of years back, the way of application deployments, it usually takes a longer time than what you expected, right? So like if you're trying to provision the infrastructure, right, you have to work with the your managers to get the your infrastructure approvals, and you want to add the storage, you have to work with the storage teams. There are a lot of dependencies, you have to work with a lot of members. So once you got the approvals, then only you can able to start deploying your application, right? Even if you have all the approvals and everything, is there any guarantee is there any guarantee your application going to work? There are 50% of chances there to work your application. The reason behind, like if your application is working in your local environments, when you are trying to run the same application on top of the some other environments, right, some of the other environments, like if you take the your application working in the development environments, you want to promote the same code into the QA environments or the production environments. There you are going to face a lot of complication and the challenges. You are maybe it may be platform version dependencies or a lot of kind of things. So there is very minimal chances your application going to work. And the second one, maintaining the application versioning or the scripts maintenance, right? If you suppose if in one of the environment your scripts are working, when you promote the changes to another environments, if you forgot something, it is always hardly track those kind of changes on the production environment, going those kind of things. To avoid all these kind of dependencies, all these kind of challenges, so by using Docker, we are going to overcome those kind of issues, right? So if you go back to the, let me show you a simple screenshot where we're going to talk about a little bit how the older traditional way of deployments, how the virtualization deployments, how the container deployments, right? Once we're done, then we are going to talk about how to do, right? How to do the hands-on practice as well. If you go to the traditional deployments, if you go to a couple of years back, the way they're going to deploy the applications, we have the hardware. Basically in the hardware it's like it is one of the servers where you have the CPUs and everything is going to attach. On top of that, you are going to attach a operating system, right? You are going to install with the some operating system. On top of that, you are going to deploy your applications, right? So that is the older days, the way we are going to deploy we are deploying the applications. Coming to virtualization technology platform. So when the VMware getting the picture or the HX hypervisor file system is getting the picture, hyper virtualization, all these kind of technologies are getting the picture. The way we deploy the application using virtualized deployments. So again, the virtual deployments, what we have the hardware on top of the main operating system. On top of the main operating system, we are going to install the hypervisor, basically which is going to be VMware or ESXi kind of virtualization technologies. On top of that, we are going to build the multiple virtual machines. On the each virtual machine, it will have its own operating system, and we are going to run the application on top of that. When it's getting the containerization deployments, right? That is the towards every organization looking toward these days, right? Which is going to container deployments. Again, in the containerization deployment, you will have an hardware. Again, you are going to have the operating system. On top of the operating system, you have a Docker, a container runtime platform, which is maybe a Docker daemon or some other container platforms, right? On top of that, you have the self-isolated application, which is basically containers. You are going to run on top of the your servers. So that is the way of deployment happening the from if you compare the older days to these days. So this is the way they are running the applications, right? This is a simple background about your deployment process, right? So let me talk about like what is exactly virtualization based deployment. So basically, a virtualization is a technique to importing the guest operating system, right? Simply, we are going to import the guest operating system on top of the host operating system, right? This technique was revolution beginning because it allowed developers to run multiple operating systems in different virtual machine running on the same host, right? If you go back to earlier slides, this is the one. If you see this one, so we have the hardware system. This is the main operating system, and we have the hypervisor, right? This is where we are going to use the virtualization technology. On top of the hypervisor, what we are doing, we are creating multiple virtual machines. Like if you want to deploy three application on top of the hypervisor, they are going to create three virtual machines, 1, 2, and 3, and each virtual machine you can run it whatever the operating system that you would like to run it, right? If you suppose if you want to run a virtual machines like a if you want to run something like a Windows operating system, you can run it on top of the one of the virtual machine. If you want to run Linux machine, you can run it on top of the another virtual machine. If you would like to run some other platforms like a iOS applications, you would like to run the Ubuntu machines. What you need to do, you just need to create a hyper virtual machine. On top of the virtual machine, you are going to install your guest operating system, and then you are going to run your application, right? So the benefits of, let me talk about the benefits of virtualization. So you can host multiple operating system, right? You can host multiple guest operating system. You can run it on top of same machines, right? and the maintenance and recovery was very easy in case of something got failure, right? If one of the VMware it got failed, you can easily revert back the changes as well, right? And the total one, if you go the cost wise, right? The cost wise, when you go compare with the traditional way and the virtualization way, the cost wise, the virtualization deployment will be less when you compare with the traditional and virtualization point of view, right? And however, there is a limitation, right? The limitation basically, each VM requires a CPU, storage, RAM, and operating system, right? To run more virtual machines, we need more resources such as CPU, storage, and the RAM and everything, and the application functionalities, and there is not that much 100% guaranteed, because we see like it may be a dependency issue, it may be application version issue, or it may be a software issue. We are going to face those kind of issues on the virtualization deployments, right? So if you would like to take more and more virtual machines, always we need the more CPUs and more RAM and the more storage, right? That is the limitation it has. And coming to containerization. So containerization is the technique bringing the virtualization on top of the system level, right? Again, Docker is not equal to your virtualization deployment. So a Docker also trying to use the virtualization concept on top of the operating system, but both are not equal, right? So container basically runs on the Linux operating system, which is going to use the base operating system, which is like your host machine operating system kernel version, right? So it going to each time, each container, when you're trying to execute your application, so we can call it as a container. Whenever you're going to trying to execute your container, each one is going to maintain its own file system and its process, memory, and the network ports and everything, right? So let's take an example. I have one of the container that is running on port 80. If I would like to use the other application also on the port 80, I can use it. That is the things, like it is using each container is going to use the its own ports and everything, right? Let me talk about the benefits of using containerization technology. So containers on the same OS kernel are lighter and smaller, right? Better resource utilization compared to VMs, right? So if we talk about the resource utilization, right? So if you compare with the virtualization technology, right? So when you're trying to create one virtual machine, right, what will be happen? You have to allocate a set of CPUs and a set of RAM and everything, right? So that is going to that the set of CPU and RAM is going to use by a particular virtual machine only, right? That is going to used by a particular virtual machine only. When you compare with the Docker containerization platforms or any containerization platform, how the resource will be used, it's going to use the shared, right? It's going to use the shared resource usage, right? If you suppose, let's take an example, your computer has the CPU, 4 CPUs and the 16 GB of RAM, right? If you have the 16 GB RAM, when you run the containers, right, what will be happen? Each container is going to trying to use the same utilization. If I'm trying to run the 4 containers on top of the same operating system, it's trying to use the same utilization. Each container will have the same utilization. Like if you're going to use the 4 CPU, it's trying to use the 16 GB of RAM and everything, right? Whereas in the virtualization, it's not going to possible. So you have to dedicatedly tell how much memory is required. Then only the virtual machines will be executed as expected. Then and the coming to boot up process, the boot up process, like when you want to try to bring up your application in the containerization technology, it will be very quickly. All you need, you need to run a bunch of commands. It will bring up your entire application on the site itself. And the deployment process is very fast when you compare with the. Hey, someone can mute from your end. I'm getting too much noise.
Hello, sir. While we are spinning up the containerization, can we
Yep,
allocate the memory?
you can. You
Okay.
can. So that is all. It depends on the application performance. Like let's take an example. uh, you have a container, you have a one of the Java application has a dependency on Java application has a dependency on is the minimum CPU is this much and minimum memory is this much and CPU relation this much and max this much. If you want to define, you can define that those things will be taken by your application. You are not defining to your container. You are not defining those things to your container. You are trying to define the utilization parts everything to your application. Your application trying to use that much CPU. So we are saying like,
Okay.
hey, my application required this much of CPU and this much of memory. At any cost, I want to use this much. So your application, you are going to set it in the application level that will trying to consume that much. Right? Whenever required, it trying to
So
consume
will
that
you show
much.
this practically? Will you
Sorry?
show this practically? Container? Will you show this
That
practically by launching a container now in
uh,
this session?
since I will try to show, since I'm not using the any Java applications, I will try to show you, but I'm not going to use the Java application during this section, right? If you want to go with that one, that is a completely different pattern. So there you have to use a different concepts are getting the pictures. There you definitely have to deal with the Docker Swarm and Docker Compose, all those kind of technology getting the picture. Then only we can able to handle those kind of situations, right? Again, this is a introduction to your Docker, and we will have the hands-on experience. I will show you how to write the Docker files. I will talk about the bunch of commands, how to use, how to monitor, all those kind of things. If you would like to go beyond that one, yeah, we will definitely work with the Micron team to try to schedule one more section, how to set up advanced level of Docker containerization platform and everything, right? So that is again different topic we would like to talk. And for now, let's continue this one. So if you would like to need more information on this one, you can directly send your feedback to the form. So we will try to respond to that request, and we'll try to provide the examples of how to handle those kind of situations. Okay. Other than that, like, again, we are saying like it's going to use resource usage. It's going to share by across all your containerization. So compatibility of application and versioning we will have in the containerizational platforms, right? So versioning and the what application versioning and the you can what it means exactly, like if you want to deploy one of the container on top of the one of the platform, you can define the versioning. So which version you are trying to run, right? All those kind of flexibilities and benefits you have in the containerization platform, right? So again, I just would like to compare the between the containerization platform and the virtual machine. So this is how it is a basic example of a basic flowchart. Here it shows like a main difference between the Docker platforms or the virtualization platforms or container platform or the virtualization, right? So if you see the first diagram, so we have the basically any organization is going to maintain their own infrastructure. On top of that, they have host operating system, right? In the host operating system, we are going to run one of the service called a Docker, right? On top of the Docker, we are going to host multiple containers. We are going to host multiple containers. Whereas virtualization
Sir, in
technology,
infrastructure means hardware.
yes, it's a hardware. You can consider as your computer. It's a simple example. Your computer. If you are using the Windows machine or the MacBook, whatever it is. So what we have, you have the computer. That computer, it has a bunch of requirements, right? It has a CPU, it has a RAM and everything, right? On top of that, you are installing your operating system, right? Once you have the operating system, everything, on top of that, you are going to run one of the service called Docker, which is basically Docker software. That's on top of the by using this Docker software, you can run multiple containers, right? Similar, if you go to the virtualization technology, here what will be happen? So we have the infrastructure. On top of the infrastructure, you will have the operating system. On top of the operating system, you have the hypervisor. Basically, which is going to be your ESXi software or the VMware. On top of the VMware, we are going to create the multiple virtual machines, right? Each virtual machine, it has its own operating system. It may be Windows, iOS, Linux, whatever it is. On top of that, you are going to deploy your application, right? So since you are trying to create the virtualization technology here, so if you would like to create a virtual machines here, this hardware should have a limit, right? If this hardware has a only 4 GB of RAM and 4 GB of RAM and two CPUs, so you cannot create more and more virtual machines. Since whereas here, if you compare to these two things, like suppose in this virtual machine technology, if I was able to create only two virtual machines, right? Since I have the very limitation of 2 GB of RAM and the two CPUs, I can create only two virtual machines. Whereas here with the same configuration, I can host up to 10 to 12 containers. with the at the same time, and the at any at the same time I can run the tool applications at the same time, right? So all it's trying to do, so whatever the CPU, whatever the memory it has, it's trying to use this container. So that is the main difference between the containerized platform and the virtualization platform. So, and coming to Docker engine, right? So in the Docker concept, it has a bunch of components. So I would like to go with the one by one components. So one of the component we can call it as a Docker engine. So Docker engine is the core of your Docker system, right? So the Docker engine where you are going to install, right? So when you install a software on top of your computer, that is going to work as your Docker machine, right? So Docker engine is basically going to serve as a client and server architecture application, right? You have the client software which is going to send a request to server that's going to do respective action for you, right? A server, which is a type of long running program called as a daemon, right? So when you're trying to install your software in the any kind of Linux operating system or Windows operating system, what will be happen? There is a one service which is going to run in your background process. That service we can call it as a daemon, right? Here in the Linux, the daemon which is called as a dockerd, right? And all the operation that you're going to perform, right? It's going to, when you're trying to execute the Docker CLI, all these commands will be interactive using REST API, right? Suppose you want to connect your Docker daemon, you are going to execute some Docker CLI commands. That the Docker CLI commands will use some backend REST API connections to interact with your daemon and get the response back, right? So again, there is a one more service called Docker CLI. The Docker CLI is the one which is going to send the request to your REST API, and the REST API is going to send the request to your Docker daemon, and then it's going to get the response back. If you see here the diagram, if you see this diagram, we have one of the service called Docker daemon, right? And the between the Docker daemon and the client, we have the one of the layer called REST API, right? What this way API will do, when the user say like, hey, I want to pull this, I want to get this Docker image, what will happen? So this Docker CLI send a request to REST API, right? Based on the request, the REST API go and get the information from daemon and provide the response back to your client machine. That's how this Docker engine will works, right? So this is a simple basic architecture for your Docker. If you see here, we have the three kind of main components. One is client, runtime environments, which is another one is the registry. The client location, basically what will be happening as a user or the Docker user, he is going to run all the commands. When the user trying to execute the commands, what will be happen? By using REST API connection, it's going to send a request to your daemon, which is the runtime platform, and trying to do the respective based on whatever the commands that you pass. Based on the commands, it call the REST API. The REST API will send the request to the your Docker daemon, and you'll try to execute the things, right? And then what will be happen? So we have one more component called registry. So which is going to store all your images. It's going to be a public images or private images, right? So let me give you the example. Suppose here as a client, I want to pull one of the image, right? I would like to get the one of the Docker image. How I'm going to get, right? Suppose I'm in my local machine, wherever I am, I'm going to execute a command called Docker pull. What will be happen here? So when I run the Docker pull, it will first directly go and connect to your registry, right? It will try to check, first of all, it's going to check whether it has an image in local machine or not. If it has image, it's trying to use. If not, what will be happen? It's going to try to connect, first it's going to connect your registry and look for whether the particular image, whatever the image that you define here, it's going to look for that one, whether that image is available in this registry or not. If the image is available in this registry, it's going to get the response back to here. Basically, it's going to download that image and trying to execute respective action, right? If suppose if the registry is in the registry, the image is not available, it cannot pull the image. It's going to show some kind of error, right? So that's why like anytime that you are trying to execute, always it's going to search for your Docker registry location. If the image is available, it's going to pull. If not, then it's going to throw some error. So this is basically a Docker architecture. This is a platform. It has a client server model. So as a client, I'm going to execute some of the commands. and the client will send a request to your daemon based on the REST API, and the REST API will provide the do the respective activities based on the response that it's going to get from daemon, right? So coming to Docker components and objects, what exactly Docker has and what are the components object it's going to maintain. Here there are a lot of components and Docker objects are available, so I will try to cover as much as possible. With that respect to the first one, I would like to component called Docker client. So Docker client is the simplest component in the Docker architecture. If you here see, we seen like the diagram, right? So this is the one in the client location, which is called as a Docker client. So what will be happen by using this one? You are going to send a request to your Docker daemon by using HTTP request or REST API, right? Basically, when I say REST API, it may be HTTP request or HTTPS request. That's what we're going to do. So Docker client is the utility which will be provided flexibility to execute the commands. Another one is a Docker daemon. So Docker daemon is the listen to all your Docker API requests and manage the Docker objects such as images and manage the services, containers, networks, and volumes. And again, like a daemon also can communicate with the other daemons as well. Okay, what is mainly Docker daemon? So again, if you are familiar with the Linux or Windows operating system, remember when you are trying to install any kind of software on top of your application, on top of your computers, there is one process will be executed in the background. There is one process will be executed in the background. So that process will always going to run. That is called daemon. So the daemon, whenever you're trying to install a software, that software will execute a daemon. So the daemon is heart of the basically the daemon, I can say it's heart of your process. If the daemon is not running in the background, your software is not going to execute, right? So daemon is going to play that much key role over here. And the other one is the Docker registry. So Docker registry is basically, I can say like where we are going to store all our Docker images with respect to our application, right? So if you would like, we need a once you build your application, we need a place where we are going to store all your application and all your application. It may be a public repository or the private repository. By default, you will have access for the Docker Hub, which is the host, which is hosted by Docker. So by using this Docker host, you can store by using this Docker Hub, you can store your Docker images the way you want. Like if you are familiar with the GitHub, so when you would like to store the code, what you are doing, you are creating the repository, there you are storing. Similarly here, you are going to create a repository on the Docker Hub, there you are going to store your images. So I'm going to show in this during the demo, I will show you how to store the images as well, right? So and coming to Docker objects. So Docker objects, I would like to talk a few that we are going to use most of the times. So when you are trying to deal with the Docker, 95% of time you will always talk about these components. One is images, another one is containers, right? Docker Hub, and the another one is volumes, and final one is network, right? So one of the thing I'm going to talk about image. So basically images are read-only templated used to create your containers. Again, the images are read-only template that can be used to create the containers. This Docker images built by either Docker user and stored under Docker Hub or in a local machine. Again, the Docker Hub you can maintain in the private repositories and the public one, right? So Docker image is built by Docker users, which means as a user, I can build my own Docker images by writing some Docker files. As external users, there are some other person who already wrote the Docker files. They're going to store the images into the Docker Hub. As a user, I build my custom images. I can also store the same images into Docker Hub location. That is about the images. And coming to containers. Containers, we can call it as a running state of your Docker images is called containers. So you might get the sometimes if anyone asks like what is Docker image, you can simply say like you can when you select images, you can simply select a read-only template used to create containers, right? That is an image. When I select a containers, running state of Docker images, we can call it as a container. Again, containers are isolated application, right? What it exactly means of isolated application. So isolated application in the sense, let's take an example. I have one of the application called Python app, right? For the Python app, so there are a bunch of dependencies that I install. So let's take an example. I have a Python app which is Flask application. That Flask application has a dependency on some other third-party library which is called Flask, and this same Flask application trying to connect the some other AWS services, so it has a dependency on also on Boto3, right? So to run my application, it required Flask application and Boto3. When I say like, right, these two, like when you are going to run your application, we have to install those two components, then only the application will try to serve. If you don't have those two things, you cannot serve your application, right? Those are the dependency for your application. By using containerized platforms, what we are going to do, we are going to prepare an image, we are going to prepare a Docker image. The Docker image will have the Boto3 and Flask dependencies, right? These two will have the Boto3 and the Flask dependencies. When you are going to execute your application, it try to use only those dependencies. It's not going to look for any other dependencies. Since, right, when like a so when you build your images, right, we are going to write some custom commands or scripts. There we are going to select, hey, these are the dependencies that I need to install, right? If you consider an example, right, so if when you are going to execute this application on some of the platform, what will be happen? So when you're going to run your container, it already has the respective softwares and all, it has the respective dependencies and everything. I can simply copy that image to some other location where I can execute it, right? That's why I call it as an isol application. If you go to a little bit different way, if you go to the traditional way of deployments, right, so there is, if you go to the virtualization platform, so I have three environments: development and QA and production. In development environments, the default package which is was installed a Boto3 which has a version to consider as a 1.1, right? So it has 1.1. When I come to the QA environment, it has some downgrade application which is just 1.0, right? So if I like as a developer, what I say like, hey, this application is running fine in my local environments or in my dev environments, but it's not running on QA environment, because the reason behind why it's not working, it has a dependency issue. The dependency in dev environment, it has 1.1, whereas when I try to execute the same application in QA environment, the dependency has 1.0. So the dependency versions are not compatible here. Okay, I treat like, okay, it may be a dependency issue. So as a developer, so I downgrade my application in development. What I've done, so to compatible with my infrastructure, what I've done, so I downgraded my dependency to 1.0 on development environments. It is working fine, and I moved to QA environment where else it's working fine. When I promoted the same changes to the production environment, again it has a dependency which is 1.0. Again, I mean, like, it has the latest version which is 1.1 version. What will be happen? Again, you have to go back and try to make the changes to make the changes on your application, and those changes will be compatible with your infrastructure. So that is like it has a one-to-one dependencies. So your infrastructure doesn't have the latest dependencies, your application, it's not going to work. If your application has the latest dependencies and your infrastructure has a low grade versions, it's not going to work. So right, it has a one-to-one dependencies kind of things. Whereas containerized platforms, your container will have the all related to your application. It doesn't matter either your infrastructure is running 1.0 or 1.1, doesn't matter. So your container will have the all the dependencies that are required to execute your application. You are simply build your image and ship it to the one of the environment there you are going to run, right? That is the concept of Docker. So build, ship, and run. So exactly the containers also work place like this. That's why I call it as a containers are isolated application platforms. It doesn't have any other dependencies with other applications, right? So here, if you see here, so if I have the Docker images, it's a layer file system, and under that, when I select, when I converted this Docker images to containers, right? When I this is, I call it as a runtime, right? When I have the Docker images, I'm simply using the command Docker container, which is going to execute, and it will be connected as a containers. So this container, whatever the version it has, the same version will be executed all the containers. So that is the isolated application. So another one is I can call it as a image layers. So images are comprised of multiple layers. Every image contains a base layer, right? What exactly means? Let's say here I have a base image. I can call it as a 1.0. As a developer, I was like as a Docker user or the Docker developer, what I've done, I'm trying to build one of application. So for that, I have added this a bunch of steps, right? So what will be happen when I trying to build the image? So first you're trying to get the base image. On top of that, it's going to execute, right? As per your Docker instruction, it's trying to execute all your examples, right? So during this time, what will be happen? So it's going to take the base image as whatever you define. On top of that, whatever the commands that you're trying to execute, it's trying to create one more step, right? It's going to create a one more layer. On top of that, it's going to write something. Then it's going to create one more layer. So right that it's going to create the increment layers as per the instruction that you define in your Docker file, right? So these layers are completely read only. So you cannot write any things after you got committed those things, right? And that is about the image layer. So another one is I'm going to talk about volumes. I can say volumes are basically we can call it as a storage. As an application, always every application will have the dependencies it want to use the data, right? It application want to use some property files, or if application want to write the some data into some location based on the requirement, or some application want to write the logs, right? Application logs into right into some location, right? So that's kind of situation we are going to deal with the volumes, right? Volumes are there are two kind of volumes. One is persistent volumes, another one is non-persistent volumes, right? So there are like some kind of situation. So you might when you work for the automation or some platforms, right? What will be happen? Some of the application it always look for that some data, it want to maintain some data. Suppose a application that generating some reports, right? So that reports want to store into the some common location, right? So that kind of situation we use a persistent data volumes. Whereas non-persistent, what will be happen as a user send a response, right? Once it got the response back successfully, that's it. I don't need that. What is the response it got generated? What is it storing? So I don't need all this information. Well, as a user, I'm sending the request, I'm getting the response back. So that kind of situation, we try to use a non-persistent volumes, right? So the concept of volumes, by using Docker volumes, we can provide the storage for your containers. So there are two types of volumes. One is the persistent data, non-persistent data. When you to deal with the persistent data, when you have an application, that application would like to when you have application that application would like to store some data, so there you can use the persistence volume. When you have some application, those application doesn't have don't need to store any kind of data, that kind of situation is going to use a non-persistent volume. When I say non-persistent volume means when you stop your container, the data will be gone if you use a non-persistent volumes. If you use the persistent volume, if your container got terminated, you will have access to your data. You can use the data by you connecting with some other containers. If you'd like to share the data from other containers, you can do it by using persistent volumes, right? So let's go back to the installation steps and everything. So what are the things to get started? What are the things I need to familiar? I can say like if you're already good with the Linux, you don't need any prior experience. So all you need to, if you have at least a basic understanding of how to write the Linux commands or the Windows commands, you should be good, right? So I would like to why I say why we need the prior experience little bit on Linux. So when you're going to talk about how to write the Docker files, you will get to know what is the importance of Linux or the Windows command line utilities, right? So supported platform for installation of Docker. Docker will support both Windows and Linux platforms. So we can follow I have provided a list of document URLs. They have provided all the steps and requirements how to install your Docker on top of the Windows, Mac operating system, CentOS, Ubuntu, Fedora, Debian, all those kind of systems. If you'd like to execute your Docker using some binaries, you can also do that one. So once you follow this document, one of the as per your platform requirement, once you have installed the software, only way you can verify it by executing the Docker version. By executing the Docker version, which will provide you what is the software version that you install on top of your operating system, right? So and then it has the API version, what is the language it got written in the backend, what is the commit ID, what is the OS operating system it's trying to use, all those kind of things that will be provided once you got installed, right? So basically once you got is done the installation part, so let me go through the a little bit a basic workflow how to handle with the your application kind of things. Anything that we are going to write, anything that we are going to write, where we are going to use a Docker file, we are going to tell all the instruction, right? So once you have the instruction on your text file or the Docker file, you are going to build your Docker image, right? So for that we are going to use a bunch of commands, and then what will be happen, like when as a client I'm going to say like a Docker build, what it's going to do, it's going to read your Docker file and send a request to your HTTP, which is basically your host machine, and based on the HTTP request, so the Docker commands will be executed, that is going to create a Docker image. Once your Docker image got created, so you can test it directly in your local, or once you got tested that application, you can push that image to your registry location. So basically this is the typical workflow that followed by any organization. So they are going to write their Docker images, they're going to build, and they publish it to Docker registry, right? So from there, anyone they want, they can access the same application. That's the Docker is a mechanism called build, ship, and run. So we are building the images and shipping to Docker registry, and so as per the environment requirement, we are going to run that application, right? This is a basic workflow of Docker, right? So let me go through, like I have, since I already have installed the all the since I already have installed my installation on my Docker, so I will show you what will happen here. So I'm going to show you here. So I'm going to show you how to verify whether your Docker is installed on your operating system or not by simply running Docker version. So if you see here, it will try to provide the information. Hey, I have the Docker version, which is 19. I have the 19.03 version, and it has the Docker engine version and everything. Oh, let me change the list. I think let me change the settings as well. Layout. Uh, let me see what I can verify. So able to see now. If you're not able to see, let me try to put this one. Okay, let me use this one for now. Change settings. Okay, I hope this time you guys are able to see. Okay, so here I use the Linux platform version. Earlier the one which I showed, which is the Windows platform. So when you install on top of the Windows platform, so you can simply go to your start button. There you look for the Docker terminal. So it will pop up for you. So you just need to open that one. That's going to install all the required packages and everything for you. So this is for the Docker. If you are trying to use the Linux machines, all you need to do, if you go back here, so you just need to run the command minstall docker-y install docker-y, right, which is shows like since I have already installed, it shows like my package is already installed on top of my platform. So let me show you what is operating system I'm using. So let's see, Red Hat OS has been released. So I'm using the Amazon Linux platform, so which is has the backend Linux kernel, so it should be fine. So this is way, like if you are trying to use on top of the Linux machine, this is the command which you have to use to install your software. So it may be CentOS or it may be Red Hat, it may be the Amazon Linux. This is the command which is going to help you to install your software, right? Once you got installed, so you have to make sure whether the Docker daemon is running in the backend. We already told whenever you're trying to install a software, in the background there is a one process will be executed. That process we can call it as a Docker daemon, right? To check whether my process is running in the background or not, how can I verify? By using by running the command service docker status. So which will tell, which will basically provide the information whether my process ID is running or not. So if you see here, it shows like a Docker PID, which is like a process identification ID, which is 3021. It shows like a status is running. So this is where I can confirm, okay, my Docker images are running, right? So this is the one will be happen, right? Let me get started with a basic example. Then we can go through a step-by-step process how to execute the how to write the Docker files. So I will show you to get started a minimum Docker steps, how to get started, all kind of things. Now, the first thing, let's try to print the Dockering or Hello World program. How can I use it for this? I'm going to use Docker run, right? I'm going to use Docker run Hello World already. So I will like a Docker container run. So again, so what will be happening here? So Docker is the my client CLI, and followed by it has a bunch of options, right? If you go back here, when I type the Docker, right? So it provides a list of all the available commands for me, right? So what is the commands that you can use it, and it has a manager commands, how to manage this one, and these are the running runtime commands. All this kind of options get provided. So out of these commands, I'm trying to use one of the option called container. So by using container, what is like, if you see here, manager commands is says like a container. So by using this Docker container command, you can manage the container. What it means, you can start your container, you can stop your container, you can delete your containers, right? All those kind of things you can perform using Docker container command, right? So that is the way we're going to show. Like, let me show you by using Docker followed by manage command container, right? So hyphen help, it will provide you what are the things that it's going to provide the information. You see here, when I say like a Docker container hyphen help, so you can use it this much option followed by Docker container command. So after this command, we can use this many options to operate your Docker images or whatever the things, right? The first thing I would like to talk about Docker container, right? Docker container run space hyphen hello world. So here what I'm trying to tell, so I have the one of the image called hello world, right? So I have the one of the image called hello world. I'm trying to execute that image by using run command. Basically, I'm trying to running the image, which is called by running state of Docker image. We can call it state a container, right? So right now we are trying to run this Docker image, right? Let's see what will be happen, right? So just keep eye on this one, what will be happen here. So I just ran the command, see here. So when I run the Docker run blah 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 image, what will be happen? It got pull the one of the image, right? It got pulled the one of image, and once the image got pulled to your local machine, then it got executed automatically as per the content that got defined. So it shows like a hello from Docker content. Now the interesting things, what will be happen here exactly? When I run say like a Docker container, what will be happen? First of all, if you observe this one, it's trying to find the image, right? It's trying to find the image called hello world icon colon latest. It like when if you didn't define the any version here, it always trying to pull the latest version, right? What will be happen? It's trying to look for this image in your local path. So if you're trying to see whether this image is available in my local computer or not. So let me go show you here to check, okay, when it going to look for whether the images are available or not, to check whether the Docker images, what are the Docker images that are available in your local computer by using Docker images space ls. So it will try to provide you what are the images that are available for your container, right? So oh sorry, this guy. Then it shows like a Once it's trying to execute, it is not able to find what will be happen. It immediately say like, I'm trying to pull the image, trying to pull the latest from this library. How it know it has to go this library? So by default, Docker trying to use the registry called Docker Hub. So which is the way all the Docker images that going to store into the your Docker Hub location. Docker Hub is the default location for your Docker containers. When you are trying to pull the images, it's defaultly trying to go and fetch the Docker Hub as per the image location. It look for the all the images that are available in your Docker Hub and trying to find with respect to the same name. Then only it's trying to pull the images. Where I mean, need to tell the this registry and everything. By default, you no need to tell. Again, if you work for an organization, you would like to pull the Docker images, right? So if you work for an organization, definitely you are going to use your own repositories or you are going to use your own private registry. That kind of situation, you have to tell which image I'm trying to pull. So by default, it's going to the Docker Hub, which has a default repository, right? If you are trying to pull the images, a custom path, right? If you are trying to pull the images from your own images, or you are trying to pull the images in your private organization, you have to define the image location. Then only it's trying to get the image from particularly that location, right? Then what will happen? It trying to pull the latest image and so on some location. Then it got pull completed and it got provided the some identification number. What is the SHA-256 key and say like a downloaded image for wall to hollow wall I call on latest images. So you say like a completely my image got completed. Then it trying to execute the container, right? So once it got executed, it print the this kind of information, right? This is what it's trying to tell. If you would like to share the images automated workflows, you have to use this is the Docker Hub location. So if you'd like to know more information, they are trying to provide some information about here. So this is what it's going to tell you. Let me show you what will be happening exactly when you're trying to run Docker run command for the first time. So if you see here, what happened when I run the Docker run for the first time, right? Now if you see, I just show you like a Docker run command. What will be happen? Docker looks for the image on this computer. Basically, wherever you are trying to execute the command called Docker run, it's trying to look for the particular image is available in your local computer or not, and basically trying to take the decision. If the image is installed, it's trying to use that one. If image is not installed, then it will go to that search for the Docker Hub for that image, right? Then if the Docker, if consider like if the Docker image is available, whatever the image that you are trying to execute, that image is available in this location, Docker Hub, then it trying to download that image and try to the image whatever the it trying to download that image as per the requirement, and then it trying to run the Docker image. That's what is going to happen for the first time. Understand? So right now what will be happen? We have already executed the Docker container right now for the first time. So this is the life cycle it got happen. So it's going to look for your local machine, the Docker is available or not. If it's available, then if it's not available, then it's trying to pull the image from Docker Hub, right? It's going to basically go and search for the Docker Hub. If the image is available, it's trying to pull that one and try to execute the your image. That is going to be Docker container. What will be happen if I run again the Docker run command, right? Let me show you that one as well. So when I'm trying to run the Docker run again, you see here. So I'm going to use this one. So again, I'm trying to run the command called Docker run hello world. If you see here, what will be happen? If you notice one thing here, earlier when I ran the Docker command, Docker run, what will be happen? It trying to pull the image and so on some location, and then only it got executed. This command. If you see this time, what will be happen here? When I run the Docker run command, it immediately starts my container. It doesn't went to the Docker Hub location to pull the image. So since why the reason behind? So since it was able to find the whatever the run hello world image in my local computer, it's trying to use that image and try to execute it. That's what happened here, right? If we go to this one, right, this is what is going to happen. What happened when I run the docker run second time? So docker, when you run the again the same docker run command on top of the same image, so it looks for again when you run the docker run, it looks for the particular image is available in your computer or not. If the image is locally available, then it says okay, okay, my image is already available, so it's going to start execute the program. Basically, it's going to start the your container. So this is what will be happen when you're trying to execute the docker commands again and again on top of the same operating system, right? That is the one thing, right? There are a lot of operating platform versions that is going to store on the Docker Hub. Let me go to the Docker Hub location and show you what are the things that are available here. If you go here, this is the where the Docker Hub location, where this is the place we are going to store all your Docker images and everything. So for this, we just need to create a one repository, and basically we have to create an account. Basically, everyone can able to create this account on top of this one. So this is a public account. You can able to create the way you're going to create the GitHub repositories, all kind of things, right? Once you have the account, you have the flexibility. You can create your repositories. Here, I can to create the repository. I can use the create repository. There I can say like this is my repository name, right? So this is my basically within the repository I have the organization which is start with this name. Then on top of this one I can put this one. If you would like to change my organization, I can use the multi-platform apps. There I can say like one of the app name. So like I can use the micronet base app. So this is the application name I'm trying to use. I have the organization called multi-platform apps. Under that, I have an app name called Micronet Base App. So this is the one I'm trying to use it. So I can, if you want, I can put the same description here as well. So once I got place the description, so I just need to click on public. So if you can click on private, it will be only visible to you. If it is a private public, so this repository will be accessible for everyone. So let's consider I would like to put it as a public. Then what is like it is asking like I would like to connect with your GitHub repositories, all kind of things you can also connect. So here once I got create my app name as a micronet base app, then I'm going to use the create that repository. So you already know how to create the GitHub repositories and a GitHub organization. Similarly, the Docker also follow the same pattern. So what if you already know how to use the git commit or the git tag, or if you already know how to create the repositories, how to push your source code into your GitHub location, it also similarly it follow the same structure. And if you're already good with your Docker, it is very easy to deal with the Docker Hub or the Docker commits, right? So this is how we can create the repository in under Docker Hub. Then we are going to say like a tags. So the tags is the location. The tags is the location. It's going to maintain about your versioning. Let's take an example. I have one of the applications that I would like to run. So I'm going to say like this is a 1.0 version. If you would like to have the latest code changes, what I'm going to do, I'm going to define the 2.0 version. Like this, I can define the tags. So these are the build commands if you'd like to add. If you'd like to link with the your GitHub, or you would like to link with your Bitbucket, so you can also link those kind of things here. So we have the timelines when the images, API actions, all the logs will be stored on the timelines. It has a permissions. Basically, you can provide the permissions to other team members as well. If you're working for a group of members, you can provide the access to the other persons, and you can also configure the webhooks. It has a webhook location, right? It also has this this under settings. You can convert this one to private repository. You can also convert into the you can delete the existing repository as well. By default, you can only get, you are not going to get any private repositories. Basically, it is 0 private repositories. If you would like to create a private repositories on open source account, you always have to pay a bunch of amount. They will give you a private repository, right? So that is about the Docker Hub. This is how we can create the repositories and everything, right? Once that is done, if you would like to search for the Docker images which are related to some other application teams or some other person, so you can search it here. So let's take an example. I would like to search for an image called Ubuntu. I'm going to search for an image called Ubuntu. So see here, it got prompted all the Docker images that one hosted by different persons. Right? It was hosted by different persons. It not only Docker, it got pushed by there are a lot of other persons as well. If you see here, this is what published in the latestly. This is a one we how if you have the filter section is as well, you have the certified Docker certified. You can select this one. You can pop up like a what are the images that are certified by Docker. It has the option called official images. Basically, if it is an official image in the sense, this kind of images that was pushed by your Docker guys. That's why they say like official Docker repositories, those kind of things, right? So that is about your Docker images. Would like to search for the Red Hat.
So these images
You
Sai,
are
cannot.
anyone can manipulate.
Sai, one small question here. If I need to use a container for organization, then do I need to make it private, or we can keep in the public, and on top of that we can install our sorry, create our image.
So since you are working for a organization, right? So if you're working for any kind of organization, the data should be secure. So that is a key thing. If you're working for an organization, you have to store your data private location. These kind of situations, you always have to store the data in a private repositories. For that, you have to pay a license for the organization. From there, you can create the private repositories and everything.
And whatever, I mean, all the images right now you are able to search. These are all public, correct?
Yes.
Okay, thanks.
If the repository is public private one, you cannot find it. If the images that are related to public, then only you can able to search it here, right? So if you'd like to look for the some other images, right? I would like to search for a Red Hat operating system. I can look for here. It will say it will provide all the information what are the Red Hat related and everything, and
So
it
these
has to
images are
provide.
free. Anyone can download.
Anyone can download. So since it is a public images, anyone can download.
Okay, we can download and we can use it.
Yeah, you can download. You can apply the whatever the changes that you would like to do, and you can push it into your private repository.
So what is the network this Docker uses?
There are like a network Docker use in the sense like there are different kind of network platforms that are available. It has a bridge, it has a host, network file system, all those kind of things, right? So we are not come there yet. So we will talk eventually that one as well. So these are the images that are available. If you see here, I look for an image called Red Hat. Since I'm going to look for is there any official Red Hat images that was hosted by your Docker, right? If I search for that one, so if I look for the official images, nothing. There's no images that was posted by Docker related to Red Hat. So since these are not the official images, so these images kind of images hosted by some other persons which they created their own purpose, right? This is how you can verify, right? If you'd like to search for a Docker image related to Amazon, right? Look for the Amazon. So if you see here, there are a bunch of images that was hosted by Amazon, and if you also see like a number of hits, like a number of hits in the sense how many members they got downloaded this Docker images. So this Docker images, it was downloaded by 10 millions plus, right? If you'd like to know whether these Amazon images are official or not, you can simply look for the official. It will tell you what are the official images that was posted by Docker. Basically, when it say official means it was certified by Docker guys. When the Docker was certified those kind of images, then only we can call it those images as a certified or official images of Docker. Right? So these are the things. So if you'd like to look for the some other platform like Alpine images. So Alpine, one of the image which is going to used by most of the organizations. The reason behind these Alpine images are very lightweight images. It has a basic uh, modules that are required to execute your container. So it doesn't have any operations like a bootable files. It don't have not going to maintain any kind of that much information. It is very lightweight. If you see here, this is the Alpine image. So it has the official images. See here, it is the official images. It was also hosted by downloaded by 10 million persons, and it has support the 6.5K star one. If you click on this guy, so you can see the what are the tags that are available. It has the tags information. See here, who what committed the changes, what is the latest image, what is the version it has, right? So it has all this kind of information. So to our demo point of view, we are going to use the one of the Alpine images. On top of that, we are going to use different packages.
So for Alpine images, the commands are similar to Red Hat.
Alpine
Is
images
it
are
code of Red Hat or what?
commands are related to Red Hat or any one of the operating systems. Suppose to like to create a folders, mkdir is the common for across Linux platforms, those kind of things. If it is coming to a installation of a software packages, right? So the software packages, the commands will be completely different when you compare with the other images. Like if you know, if you're trying to install a software called HTTP on Red Hat or CentOS, you use yum commands. If you're trying to use the same packages on Ubuntu platform, what you use the apt-get, right? So whereas in Alpine images, we are going to use the command to install any kind of commands, we are going to use apk commands, right? So basically application package management commands, which is the APK. I think it's going to use it by Debian operating systems.
Sir, is it safe to use unofficial Docker images because there will be a for security reasons?
Like when it say
We,
official image,
we got
yeah,
a
when it say official
virus.
yeah, I got. So when it say official image, the difference between the official images and unofficial, right? So the official images, the way in the Docker or the host providers, the way they're going to test, they're going to validate all the security standards, whether it has the respective security patches, it has the respective standard kind of permissions, all those kind of things. It's going to validate by providers. When it's a unofficial, right? So let's take an example. So if I take this example, if I take the Alpine images as a reference, as a base image Alpine, right? Once I take that image, on top of that, I'm trying to install some of a bunch of softwares, right? When I install the software and everything, so my application is running fine. So then I push that image to my Docker Hub. When I push that image to that one to my Docker Hub location, now onwards that image, whatever you push, that is an unofficial image. That's going to be an unofficial image. If you ask me a question, is it okay to use unofficial images? So that is depends on the organization. That is depend on the use case that you are working. Right? If you're working for a organization which is related to financial or the security standard kind of things, so unofficial images are highly unrecommended. If you're working for a right, some organizations say like e-commerce project kind of thing, so there you can use it, this kind of image. Again, using unofficial images is completely not recommended. So better to use the images that is hosted by some trusted providers. Right, so other than that, so they have provided if you have any issue with this kind of operating system, so they have provided the link to create any issues. So this is where you can create the issues that are related to your Docker Alpine images. See here, so everyone trying to use the same images, if you have any issues, you can create a request for them. They are trying to help you to fix these issues as well. So when I say like this is the main benefit using official Docker images. If you had some issue with your Docker images, you can simply create a request to them. They will help you. If you're trying to use the unofficial images, if you had an issue, no one come and help us, right? So that is the main reason try to use the official images. On top of the official images, if you install something that software is not working because of these patches, you can raise a pull request to with these guys. If someone push some other images, you are trying to use that one, it has some issues. If they are not ready to provide the support, so then again you will be in the situation you are not able to move forward.
Sai, these are all kind of template that we can use, but I mean, obviously we can create our own image as well, right?
Yeah, you can create on own. Like we are going to use these images as a base images, right? Since we are base image in the sense that is an optional images that we are trying to use while you are trying to create your own images. If you, while you are using a base image official Docker images, you're trying to add your all the application installations and everything, right? What will be happen? There is some issue got happen. Some packages got crashed. Some application due to some reason, some installation got crashed. That kind of situation, you can raise a request to these providers, right? If you like, let's take an example. There is a some person, some X person posted a Docker image to the Docker Hub, right? Hosted a Docker image to Docker Hub. If you are trying to use that images, something got happened, right? Are you thinking you are going to get the help from that person? No, you are not going to get it. Since that is an unofficial images, he's not ready to provide. He done some practices, it was working for him. When is you are trying to use it, it's not going to work for you. The reason behind, he's trying to use it for some other purpose. You are trying to use some other purpose. So there is a lag between the information between you and the other guy. So that way you're not going to get any kind of support. Whereas if you are trying to use the official Docker images that was hosted by a trusted providers, it may be Docker, it may be Alpine Linux, it may be Ubuntu, it may be Amazon Linux, you always get a support from those kind of providers. That's why I highly recommend it. Try to use the trusted Docker images. Okay,
And do you
so
think like this kind of things, if you are using, then this I mean, people who have sub published this, they will charge something, or it's free completely?
it is a free open source.
Yeah, thank
It
you.
is a completely open source, so you don't need to pay anything here. So this is where you can use the Alpine images and everything, right? So that is about things. Let me come back to my command line utility. Let me search for the run the some of the commands and see. I will show you how to build the images in as well. So if I look for the Docker, so there is a command called search. There is a command called search. So by using search command, you can install instead of pulling the images directly to from the Docker Hub, you can also do it. Look for what are the images that are available with this particular name and how many persons are trying to use these images. So based on that, we can try to pull the images as well, right? So you don't need to go back each and every time to the Docker Hub, try to find the information, all those kind of things. So better to if you are good with your command line utility, so try to use the commands. That way you can get the more practice on the Linux as well. So here I'm trying to use the Docker search, right? That I'm trying to search for the image called Ubuntu. Let's simply take an example. I'm trying to search for the image called Ubuntu. Ooh. Here there are a bunch of images that are available when I run the command. Sorry, there are a bunch of images that are available when I run the command docker search Ubuntu. What will happen? So it got provided the name, and it also has a description, and it also has the stars. Basically the stars indicates rating. Basically it's about a rating about the this particular images, right? That's what they're trying to provide here. So and it also provides the information, say like a official or not, right? That kind of information you can search it. Like if you say like, hey, this image looks good to me, this is an official image, so I can simply pull this image to operate my things. So that is how you can find it, right? If you'd like to know command called Alpine image, right? So this is a command. It try to show you what are the images, Alpine images that are available here. So what are the Alpine images that are available completely, and what it has the images ratings and everything, so official or not. It's going to show you. If you see here, when I run for the Docker search for Alpine images, if you see here, it got printed almost this many count, but out of this much, it has only one official version, which is this one, Alpine image, right? All the rest of the images, so other users trying to make some changes, they're adding their application codes and everything, right? So that is the difference between the official and unofficial. So this one, you will always have a stable releases. If they have any issue, they will try to provide the support as well. And whereas the rest of the images, you are not going to get much help on that one. Right. Second one, if you would like to provide search for the another vendor, you can search for the Amazon. They'll provide the what are the official images as well. So see here on the all the rest of the things, it was hosted by some other persons, but those are not official things. If you see here, this image also hosted by Amazon, and but still it's not a trusted image. The reason behind it may be some of the functionalities that are not working as per the standard, right? As per the Docker standard, these had might be a security issue, there might be a compliance issue, or any kind of situation. That's why the Docker itself, they're not saying like it's not a official images, right? That is the reason between official and that's why always try to use the official images. Okay, that is about one of the command called Docker search, right? So let me talk about a bunch of commands that we mostly use, right? The bunch of commands that we mostly use while you are trying to operate with your Docker kind of situation. So one of the commands that we seen earlier, which is Docker run, which is basically trying to tell you Docker container run. You are able to run the to start a image, right? So this is a basic command to start the your image, right? Once you started the image, it will be counted as a Docker container. So it got printed this image to check whether what are the containers currently running, right? What are the images that are currently running here? Docker container space ls. It will pull you what are the containers that are running currently. If you see here, there are two images which are running for me, right? There are two images which are running on my local. Other than this, there is no other containers running. If you ask me a question, okay, if you ask me a question, what happened here? What happened here? I just ran a command called docker run hello world. Where is that container? What happened to that container, right? You would like to know that is the information as well. So when if I look for the this is it here, it shows like what are the containers that are running. If you would like to know about the information that are existed as well, right? So that way we are going to use the docker ps-a, which will provide you information about exited, right? What it means, like you just ran the command called hello world, it got ran successfully and exited, right? That's what happened. Like this is where it's going to show. Like if you see here, they're trying to execute one of the command called hello and exit. That's it. They define the way they define the code. That's it. It's not doing any other application. You are simply sending the request, you are getting the response and exited. That's what happened. Let's take an example here, right? If you run the command called ls, what will be happening? You have sent a request, we send a request, it got the provided response and exited. Similarly, it what happened when I run the Docker container. So to check all the existed containers on your operating system, I mean like on your Docker platform, what we are going to use Docker container ps-a, which will list all the existed container on your computer, right? So the other one we always would like to know how to interact with the your Docker container. So let's take an example here. Okay. Let's take an example. I would like to interact the one of the Docker container. So since I have the key file authentication and everything, I have the username and password, I was able to log into this computer. Similarly, how can I authenticate the Docker container? So, or you can also tell how to interact with the Docker container, right? For that, let me take an example. I'm taking the one of the operating system. I can call it as maybe Ubuntu or anything that I would like to. Right now, I'm trying to take the operating system Ubuntu for now, right? So, first let me check whether the Docker image is available or not. So if you see here, there are a bunch of images that are available here. Out of these, I don't have any image. I don't have any image that are related to Ubuntu operating system. Let me first try to pull the Docker image from Docker Hub. Now what I'm going to do, I'm going to look for Docker search like Ubuntu. Let me check. Oops. Let's see. Okay, Docker search Ubuntu. Okay, I see there is one of the image which is called the Ubuntu. It has the official one. Okay, looks good to me. I'm going to try to pull that image. Docker image pull Ubuntu. So it's trying to pull the image using by latest tag, which is it always has the latest tag from the repository here. Right now, my image got successfully downloaded. Let me check here whether the image is downloaded or not. So by using the command docker image space ls, it will showcase to me what are the images that are available in my current operating system. If you see here, this is the Ubuntu image, right? It has the tag which is latest one, right? It has the image ID, which has the image ID which is this one, and it shows like a created five weeks ago. It has a size 73.9 MB. You might raise a question here. Hey, I just pulled the Docker image from my Docker Hub. Why, like that is the case? It should supposed to show to me within a minute or 2 minutes or 3 minutes, with just within a few minutes back. Why it shows 5 weeks ago? The reason behind, when you're trying to pull the image from the Docker Hub, right? So the Docker Hub will try to print the image when officially publish it to the Docker Hub. So it basically trying to tell you when was the officially image was posted to Docker Hub, not to your local location. That's why it shows like a 5 weeks ago. So it looks like this image was published into Docker Hub 5 weeks ago. That is the reason it's trying to pull the hidden information here, and it has a Docker image size 73.9 MB. If you compare with the regular operating system or containers, so regular operating system you always should be see like a 1 or 2 GB kind of things, whereas here it has 73.9 MB, right? So which is good. So now that's why we call it as a these Docker containers are the lightweight and the fast in the booting process, right? So let's take an example. I want to connect this Docker image. How can I interact with the Ubuntu machines or the Ubuntu images, right? To interact with these kind of images, what we have to do, you have to run the command called docker container, right? Docker container run, which is going to execute the image called Ubuntu, right? So this time, what I'm trying to do, I'm trying to interactive. So I'm trying to interactive to the terminal, right? So I have to tell the what I'm trying to look at. That's why I'm going to use the -i option, right? So since like images are always done in interactive mode, I would like to interact the terminal. So I have to use the Ubuntu Docker container run. I have to tell the -i interactive to the terminal. So I'm going to use the -pflex, which is basically trying to take the terminal, right? And then I have to provide the image name. Since I'm trying to use the Ubuntu image, I have to provide Ubuntu. Then I'm trying to tell what kind of terminal that I'm going to use it. Here I'm trying to use the terminal called /bin/bash. Since you have see here, so when I run the command called docker container run, so on this one, it immediately got executed here. Okay, let me show you one more thing here as well. I would like to showcase one more thing to make sure what will be happening here. So I got open the another terminal. So I have the another terminal which I open here. If you observe here, so I just ran the Docker run container, so I was inside the container, right? Let me show you here. Docker space container space ls. Let you will see one, if you see one thing, notice here. This shows like a this image like basically the Docker container got started, which has the container ID this one. It has it using this image. It trying to execute the command called /bin/bash. So if you see here, so whatever the command that we're executing, so that it's going to provide under run instead of the command. So it shows like a run instead of the bash command, which was created as 30 seconds ago and shows like a 36 seconds onwards it is up and running. So this is the one thing I would like to showcase here. Now just keep it in mind here. Let's see what will be happen after we terminate exit from the container. So that also would like to check it as well. So for now I'm going to close this one. So let's see here. So if you would like to run my commands, whatever the things here, so I can create what are the commands that I would like to. So I'm going to run the mkdir hello folder, or I can create my folders mkdir micronet can create this folder, right? The folder was created here. So if you would like to check for the micronet folders, I can run this one. So here, let's FNL, I can see there's nothing here. So here the permissions of my micronet folder. So these are the permission it has, the owner of this one, all this kind of information I can do, right? So when I, okay, remember here, when I exited the command, right, when I exited from this location, what will be happen? So the section will be terminated for your container. So basically the bash section will be exited. Basically the container will be automatically stopped for you. So since we are exiting from the container will be automatically stop for you. You don't need to stop again and again. When you run the command exit, it automatically stop for you. So, and one more thing we have to remember here, when I run the command exit, whatever the changes that you perform here, right? Let's take an example. We create a folder called micronet, right? Let me try to create one more file called micronet.txt. So inside that I can put my content as well. Micro, oops, sorry. I can use micronet .txt. I'm trying to write some content here. I'm going like a introduction to welcome to micronet. Right here, I put the some description as well. Okay, let's look at the micronet folder here. Micronet. I have the content called like a welcome to micronet IT solutions. Whatever the information that I defined here. So what will be happen when I exit it from container? So what will be happen when I exit from container? When you exited from container, the when you exited from the container, then immediately you are going to lose all your data from the container. Since we just interacted, whatever the action that you would like to perform, we are doing here. When I exited from container, so all the data that will be gone. Let me show you what will be happening here. So here I'm trying to exit from container. So I got exited from a container. So I'm going back to other terminal to show you whether the image is running or not, or containers are running or not. If you see here, this time it's trying to run only 2 containers. Earlier it is trying to run the Ubuntu container as well. Earlier it was trying to run the Ubuntu container as well. This time it was executed, it has only 2 containers. The reason behind, when I exited from the container, so this section will be closed, right? This section was closed and the container will be exited. Since the section is not available, so I know it to be run, that's why container will be exited automatically. So that is the one thing. And what will be happen to my data? So if you ask me that question, so the data also will be gone. You cannot revert back those kind of data as well. That kind of situation we have to deal with the volumes, right? So that is the again separate concept. Let me try to do the some more hands-on this one, then we'll go to the Dockerfiles as well. Okay, here I got exited from the container. So let me go back and check whether I have the data or not. So I'm going to try to execute the same command, docker container run -i interactive -t terminal, which is trying to use the image called Ubuntu. Then I'm going to use the my terminal as like a bin bash. So if you see here, I don't see any data here. Earlier I have the micronet folder. So see here, I don't have my folder. So I have created these 2 files. I don't see anything. That is that means when you exit from the running container, the data will be terminated automatically. So that is a one thing. So the other one which I would like to talk about. So if you would like to start with the, if you would like to exit from here, you can also do it. If you would like to similar, if you would like to interact with the Alpine Linux, right? Alpine.
So you mean to say that the data is in non-persistent volume?
The data will be called, yeah, basically that will be a non-persistent. So when you say data
Here
will
the
be gone means
volume
like a,
comes into picture. Here the volume
sorry,
concept comes into picture.
yeah, we are going to talk about the volume concept. Here what will be happening here when I'm trying to run the Docker container. So I got interacted with the containers, I got executed a bunch of commands, and I got created a sum of folders. When I exited from the container, so the container will be automatically terminated. When it got terminated, the data will be automatically be gone. Since this is a non-persistent container and we are not using any kind of a data kind of thing, any volumes or any kind of things to store the data, right? So to overcome that kind of situation, we have to use the volume concept, right? So now the other one I would like to talk about. So if you'd like to handle with the Alpine Linux, so the Alpine Linux will try to use, I think, shell pump, and that's why I use the /bin/sh. So if you see here, it's trying to pull the image, and it got pull the images, and since the Alpine image is not available, it automatically pull the images directly. It automatically pull the images. Once it got pulled, it got executed, it got successfully completed, then it got connected the Alpine Linux as well. If you see here, so I can see the this time Alpine images, right? So these are the options. This is a way you can connect your Docker machines and everything. I mean your Docker containers, right? So other than that, let me go back here. So I would like to showcase some of the commands here. So Docker, you would like to connect your Docker container, right? So you would like to check what are the images that are available. You simply run the command docker images place ls. It will list all the images that are available in your local workspace or in a Docker location. So this is where you can validate what are the images. So you would like to check what are the running containers. So what are the running containers? By using Docker container space ls will list all the running containers for you. You would like to see what are the containers that are exited, right? You would like to see what are the commands that are exited from the running state to terminated state. You would like to see that kind of things by using Docker ps-a. It will list all the exited commands for you for the point of your Docker containers. So it's going to list all the existed containers, right? So that is the one thing, right? So other than that, let me go to the one more little bit forward. So we got talked about this one. So we had this completed. Okay, so another one I would like to talk about. Once this concept is done, the other one I would like to talk about uh, how to delete an image, right? How to delete. Let me show you here. Here, if you see here, there are a bunch of images that are available in my computer. Since it has 150 or 5.0 MB, 73, all these kind of things, it will trying to consume the storage in my computer, right? I would like to clean up my workspace as well. If I'm not using all these images, I don't want to maintain on my local. How to handle these kind of things? To delete these kind of images, what we have to use a command called remove docker rm command. So by using docker rm command, you can remove all the images that you are not using, and also you can also remove the containers as well. Let's try to remove the images that we are not using. So here I have the option called docker rmi, which is going to remove the one or more images, right? Let me show you here. Docker image space ls, it has a bunch of images. I'm trying to remove the one of the image called ubuntu, right? To remove that image,
Sir, on
what
the
I have to
host,
do?
on the host where it is created these images, where it is stored.
Yeah, it is under /var lib docker. Oh, it will be stored under containers. Let me show you from there here. So the builder, db, yeah. So overlay, yep. This is the way it's going to maintain all the informations. Here it has all the information, what are the images that you pull and what is the information it has. So it should be like, if you want to try to find about the information about everything, so the images to information will be available, all that are related to your running containers and everything will be stored under docker var lib docker, right? This is the location. It will maintain all about your Docker images, runtime, or network related information, volume information, the trust or the temp location, all this kind of information will be stored under this location. So if you have to go through all these kind of options, will or you will get to know once you start working with the familiar with all these things, you will know what happened exactly when you run the Docker images, where you're exactly storing, when you run the containers, where exactly storing, when I create the volumes, where exactly storing, when it right. So when you're trying to use the networking concept, where it exactly storing, and when you're trying to use the overlay, or all this kind of concept, you will get familiar when you start working with the uh, line by line, right? So this is the location. You can find it where libdocker under images. You can find all the full images under this location, which will maintain the all your versioning and everything, right? So now I'm trying to remove the image. I have one of the image which is like Ubuntu. I'm trying to remove the images. We just see the command called docker rm image, right? This the image is the manager command and followed by option, right? The image rmi remove, trying to remove the image called rmi, so which is Ubuntu. So if I have to define like this, right, using reference blah blah blah. If you see here, unable to remove the repository with Ubuntu most force container, it got used by something like this. So to remove this image, what will be happen? So we have to look for what are the images that are whether this image using by any other containers that are related. It may be running status or the active status, right? So we have to check those things. So let me go back here. Docker container space ps. So you see here ps -a ps is going to show the ls. It shows the running containers. ps also shows the running containers. ls-a it shows all the existing containers for you. ls-a, if you use the ps-a also, if ps-a also, it will show all the exited containers. If you see here I have the image called Ubuntu. Let me try to remove these two containers. Docker rm to remove the Docker containers, we are going to use the Docker container rm. So earlier to remove the Docker images, we use the command docker image space rmi. This time we are trying to use the Docker container space rm, the container id. So it will delete the container id. If you see here, image got deleted, container was deleted automatically. Similarly, I have one more container here, docker rm docker container rm space the container id. So it got deleted. You see here, so you see here, now I lost my Docker Ubuntu machines as well. This is how you can delete your Docker container. If you would like to delete the Docker images as well, let me come back here. So we already seen this option, image ls. We already seen this one to remove the image, docker image rmi, remove the image. Then we are going to pass the image. You can pass the repository name or you can pass the image id as well, right? If you can pass any one of the information, it will be deleted as well. Let me try to push the Ubuntu. So let's see what will happen. See here, so when I select a docker image rmi, it got deleted everything, all the information that are related to your images. Let me try to show the image space ls. This is how you can delete. Let me try to delete the one more component called using offline using
Sir, images
image.
images are also deleted in the layer wise, layer by layer.
Yes, yep. The layer it was created, it was deleted layer by layer basically. So all these layers, it was created when you're trying to build this image. Since we are not building any of these layers, these images layers was built when you're trying to build this image by officially, right? When you pull this image, what will be happen? Whatever the layers that was created by this particular image, it trying to pull all those changes. Like when you see about how to write the Docker files, how to push the images, there you came to know how to deal with these guys as well. You can understand more and more on this one, right? So when you're trying to build the images, whatever the layers it got created during the build time, the same layers will be pushed to your Docker hub. When you're trying to pull the images, you're trying to pull the same number of layers. When you're into your local machine, when you're trying to delete the image, it always trying to delete the same number of layers from your local. Right, if you're trying to remove the image using content image id, you can pass it like this, it will be deleted for you, right? If you're still trying to use something, I can use, let me say, -f. See here, when I use the -f, what will be happen in the back end? Also it got deleted completely. So here it was completely deleted everything. So like this pattern, you can delete the delete the images or containers and everything, right? So the another one I would like to show you here, how to stop the container. So there are some containers which are running. Let's take an example. I'm not using this application, this container anymore. I would like to stop or kill that container. So I don't want to use anymore. So I would like to stop a container that images. How I can do it, right? So if you kill the image or if you kill the container, you cannot revert back. If you stop the image container, you might try to restart it as well. Right? Let's take an example how to kill this container. Right? To kill this container, docker kill docker container kill across this image. So if you remember, if you are good with the Linux, if you go back to a little bit your Linux skills and everything, if you remember those kind of things, you might know when you're trying to change the shell, we know how to change. When you're trying to kill the process, we know how to kill the process by using kill command. When you're trying to remove the folder or the files, we use the rm commands, right? If you see, all the commands are similar to Linux to here. Those commands will be repeated similar pattern here, right? That's why you always have to get a prior basic experience with the Linux basic commands, right? If you are trying to stop the container, see here. So I got stop the container, it got killed. It means like it got terminated, right? Let me go back to ps ls-ea. It will show the exited container as well to me. So if you see here, it was exited created 8 hours ago, but it got exited 8 seconds ago. So this is how it's going to show this to me as well. And there is a one more container which is still running for me. So this one is trying to show you this container is still running as well, right? Let me try to stop and see where we can able to start the container back as well. Right here I have a container which is starting with this name, right? This is the container ID and it has the image name, which is one. This is the image it's using. It has the execution command. These are the things it was created, and it has trying to map with the port. So 5000 it got ported here, and it has a one of the name called focus focused underscore mode. So this is the name it got assigned automatically. Again, this name we don't need to assign. This name will be created automatically when you start any container. The name will be one of the random name will be assigned to for your container as well. Right now, this time what I'm going to do now, I'm going to stop the container called this container ID. I'm going to stop this one. If you see here, so you're trying to stop the container. Let's see what will be happening here. So stop, always we already know how the stop and the stop kill will have the different functionality. Stop will trying to send the stop signal once you got the response back from the application, then only trying to stop. Whereas kill, it will try to kill the process immediately. It's not going to wait for any confirmation. Here, if it goes here, container ls, there's nothing is starting running right now. So you would like to start back the image again, right? That you stop. So you can try to use the docker container start. Simply pass a container ID. Let's see what will happen. So here the image got started back. See here. So the image again it's up and running. So this is how you can stop the container. You can start the container, right? You can do the whatever the action that you would like to perform, right? So this is the basic commands that we are going to use in most of the situation in your real-time organization as well when you're trying to get started. So these are the very basic commands are very useful to get started your Docker. So all we have done so far. So we pull the images, we are running the images, we got validated what are the images are running, what are the images that we have, we validated what are the images that are running, and what are the containers that got exited, and we know how to stop the container, we know how to kill the container, we know how to we know how to delete the containers as well. So these are the basic commands that we've seen here. So if you're familiar with all these kind of things, let's get back to the how to build the custom changes, right? So far what we done, so someone published the Docker images to Docker Hub, so we use that images. Now as a developer or the automation is, I want to build my own images, how to build these kind of things, right? How to build the custom images as per your requirement. Since there is some images is already available, I'm trying to use. So how I would like to build my own custom images, right? So this is where the Docker file concept gets into the picture. So this is where the Docker concept will get into the picture. Again, the Docker, by using Docker file, we can build the custom Docker images, right? In the Docker file, we are going to tell what are the things that need to executed, what are the things that need to perform, right? Let me go back to my slide. So Docker files. A Docker file is simply a text document that contains all the commands, right? So your user could call on the command lines, right? By using Docker files, you can build the Docker images automatically by reading the Docker file instruction whatever we define. By using Docker build command, we are going to create the Docker images as per the instructions that we define in the Docker file, right? So let me go to the one of the image that I have, so which is going to have the all the options, right? What are the options that we can use during the Docker while you are trying to write a Docker file from scratch? So if you hardly remember this 10 to 15 commands, okay, 10 to 15 options in your Docker, you are done with the, you are good with the Docker, writing the Docker build images and everything. So if you remember with the how to use the Docker commands, then you are ready to write the Docker files and you are ready to execute the deploy your application also in your environments as well, right? Let me go through one by one examples what we have. So we will try to cover almost all the options that we have right now. So we will try to cover those kind of things, right? So one of the first one we would like to see, which is a command called from. So the from is the option which is trying to help you to set the default images and everything, right? Let me go back to here. So let me go back to my local. So I'm going back to my terminal. So let's start with the writing the Docker file, right? So how to write the Docker file, then how we are going to see, try to deploy the one of the sample application and see where we are able to build that application, and then we are going to ship that application to the Docker Hub. Then we are going to run that image into multiple environments. I will show you how I will try to run that image into the two platforms. One is the Windows, and I'm going to run the same image on top of the Linux platform, right? So that is the things I would like to showcase today. So once that is done, I will try to show you what are the things that we have to make sure when you're trying to run the Docker files, what are the standards that we have to follow, right? So let's take an example. I will try to showcase two kind of examples. One example, how it will be useful for system administrations. The another example, I would like to showcase to how it will be useful for developers to get hands on Docker, right? Let's get started with respect to sysadmins. I'm trying to install one of the software called Terraform, right? So then see how we are going to execute the Terraform into multiple platforms as well, right? First of all, to get started here, so I hope everyone able to see this screen as well. Let me create one of the folder called mkdir micronet hyphen sysadmin hyphen terraform. So this is a folder I'm trying to use for this one. So I'm switching to another folder. So here I'm going to start all my instruction, right? So to get started here, what we have to do, we have to know what are the options that are available and what are the things that we are going to perform. So first of all, I would like to use the one of the Docker image. So I have to use the one of the official Docker image. So for that, I have to decide which image I would like to use, right? For that, let me search for the sum of the images. Based on that, I can decide which one I want to use it. So I'm going to look for the image Docker CARCH, and I would like to look for the Ubuntu.
So spelling mistake.
Yeah. So here I have the option. I have the one. I look for the one of the image. It shows like a this much size. This is the image, and it has this much everything. Okay, it looks good. So it has the 10,951. So when I'm trying to pull the image, let's see what is the size of that image. So I'm going to pull that image. So I would like to use a very light one. So I'm trying to pull this image and see what is happening here. So instead of this one, I can also go to here my Docker Hub location. Have my Docker application. I can search for the size as well here. So I can go to here. I can look for click on this one. We can see the tags. It has all the information, 27 MB, all this kind of things, 31, right? Since this has this much size, So this is the one option. So I can try to use this one. So I look for the another one as well. PLPI and Alpine. So let's look for the what is the size of this one. So tags, it has shows the 2.6 and 2.5, 2.4. Yep, looks like this is very lightweight. So I'm trying to use the lightweight one, which is going to use. And instead of trying to use the latest version, let's try to use the one of the version which is the stable version, right? So since it is a stable version, I would like to use a 3.112.0. So that is the base image I would like to define in my Docker instructions, right? So for that, what I'm going to do right now, I'm in the Micronet sysadmin Terraform folder. Here I'm trying to write the Docker file. For that, I just use the vim editor. So I'm going to define the file name as Docker file. Right, so this is where I'm going to define. So I'm going to put it like some comments. If you'd like to define your comments, you can put the hash as well. That is not going to cause any issue. So if you already know how to define the things, I can directly define the options from. So from is the option. So if you see the slide as well. So from is the option to set the base image for subsequent. So we are trying to use the from option to define my Docker image. Right here, I'm trying to define my Docker image, which is Alpine, and it has a version 3.12.0. So if you see here, if you go to the Alpine tags, right here, we're trying to use the image which is 3.12.0. This is the image we are trying to use, and the ALPINE, that is the image that we are trying to use. Right now, I got defined my images, which is good. So now I have defined my base image. So by using from, right, the basically the from is instruction is trying to build the Docker image by using as a base image this one. So by using from, you are going to define the base image location, right, or you are going to define the what is your base image. That is the one thing you are going to define, right? Once you have defined the things, now we are going to use the one more option called labels. So labels is the location, or in earlier days they have one more option called, to go back here, maintainer, right? It has a maintenance. So set the other field are generated by images. So this, like, if I would like to talk about here, so maintainer, again, it's kind of a key and value. So you're basically key value pay, right? The maintainer option will be going to deprecated. That means the maintainer information will be, option will be, they are going to take away. So instead of that one, we are trying to use the label option. If you would like to use the maintenance, I can showcase that example as well. So all I need to define here, so maintainer, maintainer. So maintainer, I'm going to select a, I'm trying to select a, who is the maintainer here. So I'm trying to select a owner of the, I can select a owner, I can select a micronet. Okay, I can put like a micronet ID solutions. That is so the maintainer for this Docker image, whatever we are trying to build. So I'm defining to the micronet. So that is where you can define. If you don't want to define like that, you can also define like this pattern. You can interpret this one. So you can also define like this. So that is another way you can define this one. Let me show you right away labels option as well, so that we can understand what happening exactly. Labels is also a kind of key pair values information. So you are going to provide the some metadata information for your Docker images, so that when someone trying to use this Docker images, it will try to provide the information what exactly to do as well. So I'm going to select a label, right? And the label, I'm going to select a, so I'm going to say like a owner. I'm trying to provide the same information here, owner contact, right? And this is the key, then followed by my value. So here I'm trying to create my value as micronet. So I'm defining like this, okay, which is good. Oh, sorry. So now I define the one of the value. Now I would like to define one more value. How we can define this one? We can also define like this. So I'm going to define use case. Okay, so I'm going to define my use case. I can put like dots, I can define underscore, whatever the way I want. So I'm going to define like a Terraform. Terraform. So I can define the one more version called label. I have to tell the version, right? So I'm going to use a version which is like a, I'm going to close the quotes and open my bases. 12.0.12 latest. I don't know what is the latest, 4 I think. So that is the one I'm trying to use, this one here. Okay, here I had defined the one of the basic instruction which is from label, which is going to create the my base image and followed by my maintainer information. Since that is option is going to duplicate it, right now it's available, I just would like to showcase that one as well. So in labels, which is basically trying to tell you what are the options that we can use it, right? So now let's put it this way. So I'm going to save this one, right? With this basic information, I'm trying to build the image, right? So to build the Docker images, what is the option that we have to use? Using Docker image or image build, or you can also use Docker build. So what I'm going to look at Docker build.
Sir, here can we check the contents whether it is correct or not? Syntax checking like that for the Docker file.
Docker file, I don't think so we can check it, but I never tried that one, so I have to check that once.
Because if something is wrong in the file, then there will be a problem while building,
Okay,
right?
let me show you here. So if you're good with your editor, let me show you here.
There should be a space for the first label. Owner
Doesn't
contact
matter. No, no,
equals
no.
to no.
Again. So here, the way you can define whatever the values. Right here, I'm trying to write the key value. Key equal to value. So if you remember how the key value is defined. So if you go to this information, right? So the way you can define the key values, right? I have key. I can put the equal to here, or I can put the a bunch of values here. Doesn't matter. You are all trying to define the key and followed by value. So it no need to be colon like this, something like that. So you can define either way you want, right? So if you want to define like this, that's not going to cause any issue. All it looking for whether we define the right syntax or not. So that is a way
How
you
many,
can define as well.
how many labels we can create in a Docker file?
You can go up to how many you want. So label, again, the label is just kind of a metadata information. If you would like to write a paragraph or message, label is not recommended, that kind of situation. So like you can add that paragraph messages. So again, the label is just kind of a provide the metadata information about your container. So when someone come and look for the what happening exactly here, so what is the use case this one? So okay, it is a use case Terraform CLI. I can put like a Terraform CLI, right? I would like to provide simple words to try to understand what happened exactly. That is the information I would like to pass. If you'd like to define more and more information, you can define how much you want. But only the problem, it always depends on how properly you are defining the information. So if I say like if I would like to create 100 key labels, if I trying to create 100 labels like this one, that is not a recommended way. Then you have to change the pattern of how to create the 100 labels using one layer. Again, you have to remember one more thing. Whenever we already told that whenever you are trying to execute one by one instructions for your Docker file, each time you're trying to create a layer. So you keep in mind, whenever if you're trying to create this one, it's going to create layer. You're trying to execute this one, it's going to create a layer. You're trying to execute this one, it also trying to create a layer. You're trying to execute this one, you're trying to create the layer. You're trying to execute, it also trying to create on top of each one. So make sure you have to avoid number of layers. So if you avoid the number of layers, you will get the better performance. That is the key thing.
Sir, you have given the Alpine version as 3.12, right?
Yeah.
That we have to check it in the Docker Hub only, or else in the Docker search can we get that
Uh,
information?
I think we can get it from local as well. Let me do.
Docker search.
Doesn't provide information. Yeah, it looks like it's not providing information.
So compulsory we need to visit the Docker website.
Yep, yep. Check some other options also.
Okay.
Based on the condition of the yeah, it looks like you have to go for all the way options.
So the file name should be Docker file only. Compulsory D should be
Uh,
cache
it,
and
it,
all
it,
those.
it no need to be. You can, like, if you define the Docker file as a, yeah, if you define this one, so when you're trying to build your Docker images, Docker will know, so okay, you are trying to use this Docker file. If you're trying to use the Docker file, let's take an example. I have a Docker file like this, right? When I'm trying to run the Terraform, sorry, Docker build, Docker treats like there is no Docker file. So then that kind of situation, you have to tell which Docker image you are trying, which Docker file you are trying to provide. So that kind of situation, we have to specify the some -f option to provide this one. Let me show you all the things as well, so that way you can understand what happened. Now let me go back to simply put in my original location. Okay, let me show you here. So here I have a bunch of instructions, right? Let me try to do one thing here. So I'm going to try to build a Docker image. Docker build UILD. If I use the dot, it will try to create the one of the images. If you see here, based on the instructions that you provided to your Docker images, each time it got created a one more layer on top of the execution, right? So for the first time it tried to pull the images, it got created one layer as like this. Then what will happen? It added the one more information, says like a maintainer, which is Micronet ID solution, and it got executed, and it got created, and it got removed this container, it got created the layer, and again it got added one more instructions, and it got created one more layer here, and again it got installed the one more instructions, it got created layer again. So if you added the number of options one by one, it keep trying to add the number of layers based on the instruction that you provided. It keep trying to create the layers as well. So to avoid this many layers, what we have to do, so if you see here, this image is got successful, right? Let me check whether the image is created or not. So Docker image space ls. So if you see here, the repository name is none, the tag name is none, and the image ID, which is one, which we built it right now. If you see here, so this is the one that we built it, and this is the one it got created, right? It has the created, which has a size 5.57 MB. So here we are missing a little bit here. It doesn't have any repository name, and it doesn't have any tag name, right? That is again complicated to understand what happening to my images. If I trying to build 100 images like this, so I cannot find out which image I built it unless if I know the timestamp. So similar kind of situation, this is the Linux operating system. There are 100 persons trying to use the same operating system. On top of the same mission, they're trying to building the images. So you might get the same similar kind of timestamp with the different image IDs. So then again, it's hard to track that kind of information. That kind of situation, we have to define a tag identification. When you're trying to build your image, try to define the tag identification. That way you can know what images you which image you built it, right? For that, how to build create the tags. So you have to use docker build -t. Right here, I'm trying to build a Docker image called micronet Terraform. So this is like I can put like a I can put like some tag name Terraform. Right? So I'm building the image called related to Terraform. So if I run this one, so my image got built there. If you see here, this time the tag got created Terraform says like latest. Now if I run the command docker image space ls, it will showcase to you Terraform then followed by latest version. This is how I can easily identify my images. Okay, that is the one thing I would like to showcase here. So now how to avoid this many layers, right? So let's come back to here. Now we are going back to my Docker file. So here I have too many layers. To avoid this many layers, what I'm going to do, I'm going to remove all this information. So I'm going to take out these labels. I'm going to say like a slash forward slash and followed by slash. Basically, I'm trying to separate the values, right? And followed by like this. So when I run this command, what will be happen? All these values will be executed at one shot, right? That's what is going to happen, right? Let me try to save this one. So before I'm going to save execute this one, right? Let me go back to my Docker image space ls. So here I have the image as well, right? I want to make sure my information was added to my Docker image or not, because earlier we built an image, right? It has a label and information and everything. So I want to make sure whether the information is available on my image or not. How can I validate that kind of things? By using the command docker image inspect. By using docker image inspect, I can pass the image ID. It will tell you what are the information it has. You see here, if you go all the way top, is the information. It has all the information path. If you see here, Docker version, other micronet ID solution. So this is the information I pass it. How to pass the labels. This is the information I got pass it here. Right. So this is the way I can define all my things as well. So to override the multiple layers. So that is the one thing. I'm going through my. Okay, here I have the labels and everything. So before that, let me do one thing as well. So I would like to get my software as well. So I'm going to get my Terraform software. So here I have the 64-bit. I'm trying to download the software. So I just need the link. So what are the things that I'm doing? I can do it through my directly from Dockerfile as well. So it will take a little bit time to figure the option and everything. So I don't want to spend that long time. So I'm just using the Terraform downloaded. So I have the executed file and everything is good. Now I'm going to remove Terraform and store here in Docker file. So I am going to add the Terraform to my location. For that, what I'm going to say, okay, add Terraform, right? So the location slash user slash local slash bin, so like a Terraform. So this is where I would like to add it. Now I'm going to make sure I would like to execute the commands as well, right? So when I say like a when I'm trying to execute my options, so make sure I would like to run this one as an entry point and followed by my options, right? Now for that, what I'm going to do, I'm going to write an option called entry point. And I'm going to provide them my information here. So this is a command I would like to execute as an entry point. Then followed by this information. Then I would like to add the command. So I'm going to select a CMD, so which is going to be command. The command which always going to be hyphen help. Here, so I have the image. So what I'm trying to like, I have the Terraform software. I'm putting on the binary location, which is local bit Terraform. And when I'm trying to execute my Docker image or container, I would like to call this script and followed by this command, right? That's where I'm trying to use it, right? What I'm going to do, I'm going to save this image. So now I'm going to build the image, Docker image, build, maybe Terraform 1.0. So I'm trying to build a Terraform 1.0. It's like this. So response local bin, user entry point, user in blah blah blah. Create Docker file, user local bin. So it has some error. Command Docker file files line name unknown instruction entry point.
So I think we need to give the location of the RPM, right? Terraform
No, no, no.
RPM.
So I don't need to provide, like I have the RPM, right? So this is the executable file. I'm moving this executable file to, let me check, I download the RPM. No, I don't. Okay, yeah, this is not it. What I've done. So I just trying to. So what I've done here, I just copy the Terraform scripts, whatever the script that I have. So I put it into the location of this guy, right? Under this guy, I have the once I had the executed file here. So I would like to execute this command. So when I run my script, it always trying to execute the command automatically. So that is the one I'm trying to add it here. So since it's not
The script file you
working,
have kept in the user local bin.
it no need, you can put it anywhere location that you want. So the
Yeah,
issue
can you
right
go
now
to
I
that
have.
location and show? Can you please
Hold
go
on,
to
hold
that
on.
user local
One
bin?
second. One second. You have to understand the situation here. I'm not trying to build the images on my local. I'm trying to pull the Docker image, one of the Docker image here. I'm trying to pull the one of the Docker here. On top of this image, I'm trying to install the software. I'm not trying to install on my local. So you have to understand the situation here. So the issue is here. So I know the issue here. So this is a space issue it has. Okay, this is the space it has. That's why it's throwing an error. Okay. So now my image got built. Now I would like to validate here whether the things are working as expected or not. Now to run this image, what I'm going to do, I'm going to take this image area as my Docker image. Now what I'm going to do, I'm going to run the command docker run, right? I'm going to docker run. I'm going to use for this one. Let's see what will happen. So here, when I run the docker run, this command, when I run the docker run, and this is the image which I built it goes provide this information. Since why it is printing this information, the reason behind, if you see the Docker image file, right? You see this Docker image file. So as whenever I trying to execute my Docker image, default try to print the help information. If you would like to override this information, I will show you how to override as well during the runtime. So this is the entry point. This is always going to be your entry point. So you are trying to execute the Terraform. For this entry point, we are trying to provide the option called help. For this entry, I'm providing the option help. So what will be happen? What will be happening here? So when I run this command, it's trying to print the help information. If you would like to over that information, I would like to say like a version. See here, got printed the my Terraform version as well, which is installed 12.6. If you would like to print plan, would like to run the plans, it's going to throw some error. So there is no configuration it got available here. That's it's not able to find it, right? So now this is how I built my image. Now my aim is like I tested my local environments. It is was working fine as expected. What I was looking for. Now what I'm going to do, I would like to push this image to my Docker Hub. To push the image to Docker Hub, what we have to do? Let me go back to my Docker Hub location. So my Docker Hub location, this is the one. So this is my Docker Hub location. Here I got created the one of the repository here, right? So here I have the repository name like this format. Now I would like to tag the image like this format, whatever the image that I have right now. So I would like to tag that one. So if you see here, Docker image space ls. So here the image which has a 1.0 version, that's what here to tag the information. Again, when you're trying to push your source code to from your Docker images to from your local machine to the Docker Hub, make sure you make sure you follow the pattern what you created here. Here I have the tags like to create the tag, right? So Docker image tag. So I'm trying to create a tag for the image. This is my source image. I'm going to use this one Terraform colon and followed by my version. Right, I have the Terraform colon followed by version, right? So here I have defined my Terraform version. Now I have to define which name I would like to define. So this is the where I have. So since I created the repository like this format, so I'm going to put it like this. Then followed by I would like to define my version. So 1.0. So now I will create my tag as well. If I run the command docker image space ls, it will show the my image like this format. So if you see here, this is the image, right? If you see here, so I have the multi-platform apps and followed by micronet base app, and followed it has a version, it has image ID and everything. So it's got created. Now what I'm going to do, I have to push this image to my Docker Hub. Now my billing part is completed. Now I'm going to push the image to my Docker Hub. How to build or how to push this image? So you have to use the Docker image push, right? So you have to use the Docker image push, which is going to push your image to your Docker Hub. When you're trying to push the image, we have to tell what is your repository and followed by version. So let me try to see here. So when I'm trying to push the image, now it immediately throw an error, says like an authentication failed. Right? If you see here, the image pushed over to so on the location, it's trying to push, it got error like a access denied. Right? To overcome that kind of issues, what we have to do, we have to log into the Docker Hub. Docker login. So now I have to provide my username and password for the Docker Hub. Okay, now my authenticating got succeeded. So automatically when you for the first time when you say authenticated, the information will be stored under this location. So the password information will be stored unencrypted manner, something like that. I don't want to fill that one. So it will be stored under that location, right? So now I can able to push my image back again. So if it's push here, so you're trying to whatever the image layers that got created in your local, you try to push the same layers to back to your Docker Hub. Here see like a 1.0 digestion, it got pushed to your Docker Hub. So now I'm going back here. I'm going to refresh this guy. So if I see there is a last push happened a few days back, this is the version ID, this is the operating system Linux, it has a few seconds as well. So it has the image version, it has the size of the image and everything, right? So these are the instructions that got added. So for the first line, when you're trying to execute this command, there's not that much space, when maintenance, nothing. When you're trying to add the file to this location, that location it got has a decent amount of size, which is 16.12 MB of your operating system. Now I have consider now I have pushed my images to my Docker Hub location. Now I want to run this one to on top of the some other platform. So for this I'm trying to use the platform as a my Windows machine. So here I have my Windows machine. Now what I'm going to run, so I'm going to take this image. I'm going to take this image. So see here, right now we don't see any, we are seeing only text, fill, time, so we don't see anything, right? So it has the 1 version and everything. Now what I'm going to do, I'm going to run the same user on my local docker run, right? I'm going to paste this URL colon 1.0, right? I'm trying to run this one, enter.
Can you please change the font of the command prompt?
Yep. Okay, you see here, so I got full image. This is a command got executed automatically, right? So if you ask me a question, I would like to, if you'd like to go back to your computer, here if you ask me like, can I run the same thing, you might have a question. I might have the Terraform in here. Trying to run the Terraform, I don't have anything Terraform command here. So if you want to make sure, I'm going to move Terraform to Terraform on a spare world. So I don't have anything which is logs Terraform. To make sure validation, the Terraform right now shows the Terraform command not form. Now what I'm going to do, I'm going to run this image Terraform 1.0 plan. It executes the error. Like if you say like a Terraform simply it's going to show like a help command. So since even I don't install my Terraform commands in my local, so still it got able to execute the things, right? Similarly, if you would like to deploy for a Flask application, any kind of things, we can also do it that pattern as well. Like that, we're going to use mkdir micronet, some Flask app. Right here, I'm trying to use my sample snippet here, micronet Flask app. So I'm going to use vi.app. So here is sample Python app. So I'm trying to pass the, so this is a path I'm trying to route. I'm trying to pass as input here and trying to pass the input. Whatever the input I pass it, I'm going to print it here, right? So it is going to run mount on the system. So if you are familiar with the Python coding, so you can understand easily this one. So I'm not doing anything fancy here. So I just build the app. Now I'm going to copy my Docker file as well. Here Docker file. So here we are saying like at this time we are trying to install the Python app, right? So we use the Python Alpine image, which has already inbuilt everything. So we just need to execute our options. So here we are trying to copy my software to this application. It has a working directory. Basically, what we are trying, like once you copy the whatever the software that you have in your local, right? So now I have to write the requirement of txt as well. Ask how the boto3 dependency, how flask. So I have the dependencies, everything. So if I open my Docker file, let me explain here. So we are trying to use the base image of this one, and then we are trying to copy the files in my current location. Whatever the files that I have in my current path, whatever the files that it has, I'm trying to copy to this location, and then I'm trying to switch the directory to app folder. Then I'm trying to run the one of the command called pip install of or required bin.txt. Then I'm trying to install, basically trying to install my package dependencies. Then I have the port numbers, like my application, which is going to run on the default port number 5000. That's why I'm trying to expose the port number to external wall, so that when I'm trying to access, I just have to mount this point to my local, I can access. Then I'm trying to execute the default program as a command Python and followed by my app.py. That is the script I'm trying to execute. Since I'm in the app folders, I don't need to pass again app slash and everything. So I simply run the /app.py, which is going to execute my Python script as well. Right? Since I have the information, everything. So now what I'm going to do, I'm going to try to build a Docker image. Build. I'm going to select a Flask app. Right? I'm going to select Flask app and see what will happen. Docker image build -p tag. We're trying to build the images. You see here, it got copied my softwares and everything. Then it's trying to install the dependencies that are required to this particular application. So since it is using some version, it should be fine. So now my image got also pulled. Now what I'm going to do, so I'm trying to Docker image space ls. So here I have the Flask app as well. So now I'm going to run this image, Docker run. Docker run, I'm going to use a Flask app dot latest. So if you didn't define anything, it will pick up automatically. That should be fine. So if you see here and the image is trying to start, then it shows like my application is serving on this one. So how to access this application? Since right now this application is running inside the container, so I cannot access this one on external components. So I would like to find a mechanism how to access this application. And still, we have defined my application port number, which should expose to the external world. Say like I expose this port to access my application. Since my application is running on this port, what I'm going to do, I'm going to mount this 5000 port to my local machine. Right? Once I got mounted this one to my local machine, from there I can able to access the application. Right? For that, what I'm going to do, I'm going to cancel this one. Kill. So I kill. So now what I'm going to run, Docker run, right? Flask path. Before that, I'm going to select a -p. So here I have to tell which app I'm trying to execute. So I'm trying to execute on 8081 and followed by my container port. So see here. So what I'm trying to do, I'm Docker run, which I'm basically Docker container run. So or Docker container, whatever the things that you want, you can define it. So Docker container run. So I'm trying to map with the port number on my local machine, which is 8081, and which is I'm trying to mount it to 5000, which is I exposed on the Docker container. So and my Docker images. Let's see what will happen. So again, I got mounted. Now this time it's got mounted, right? We already defined this one. Now I'm trying to access this one using my public IP address. Now what I'm going back here, I'm going back to here. I'm trying to access the application, so which is on 808. Ping the right IP address. See here. So by default, I got the response like a not one. So you can also see observe the logs here as well. So I'm not doing anything fancy. So here it's trying to get the response as a not found. So I'm going to put, I had defined in my code /home, then followed by my name. So I'm going to provide like a micronet. Whatever the information I defined, so it will pop up the information here. So here I got the response invalid, got the response 200, so I got it able to run. Now, so this is how you can map the port numbers and mount it to your local network as well. So if you would like to ask me a question, so if I close this section, my connection will be gone. So how can I override this kind of issues? So this kind of issue to override, what we have to do, we have to run it this content on the detached mode. How to run the containers on the detached mode? Let me show you that one as well. So I'm going to stop the existing container again. So I'm going to docker kill. I'm going to use this one. So I got killed the Docker containers. Now it got stopped. To run the same container in the backend, right? What you have to do, I have to use the option called -d, which is going to run the detached mode. So when I run this command, the container will be run in the detached mode. So I can see here. So I'm not able to see anything here. So it's just in that container ID. If I run the container space ls, so it pointed the information. So like up 801, it has this information. I would like to see the logs about my container since I don't have it's not printing anything right to me. So I would like to see the logs. I'm going to use the log docker logs. I get a container docker container logs. I'm going to print this guy. So here see it got start printing here. So if I'm going to use so I just put it like a tile mode, like if I use FNAF, it will try to provide the real-time logs, and I'm trying to access my application one more time and see whether you're able to stream the logs or not. So now my application is still serving. Now I'm going back here. See here, when I send the request, it got the 200. I put the response as a micronet. Now what I'm going to do, I'm going to put like a Docker. So it has printed the 200 response. Now I'm going not passing any information. Let's see what will happen. So it got the file not found, which is going to 404. If you see here, you are going to get the file not found. Like this, you can Dockerize any kind of applications, any kind of application, and any kind of application on your local platform. And you can push these images to Docker Hub, and then you can run it wherever you want. So that is the concept of build, ship, and run. So that way you can speed up the deployment of our application. If something got happen, I can revert back, right? If you see here, I would like to run same kind of images 2 times. I can also run it that pattern as well. If I would like to see here, I would like to run the same app on 5000. I was able to run. Let me put this on 8084. I was able to run. If you would like to run the same thing on 8085, I can able to run. Since these applications are isolated application, there is no dependency one-to-one, so I can run anywhere I want. So here I use the 8084. I put like a 8084. I'm putting like a same information. So this is from 8084. So if I use the same information, I'm going to put it like a 8085. I got it from 8085. Now what I'm going to do, I'm going to terminate one of the container. I'm going to kill the 8084. So still I can able to access the 8085. If I trying to access the 8084, it's not going to work since we already terminated that container. See here, it's not working. So that is the mechanism of you can self-heated this kind of application. If might arise a question, I want to run I would like to handle the high traffic, the more and more traffic. How can I handle this kind of situations and everything, right? So this is where the concept of Docker Swarm, right, or the Docker Swarm concept will get into the picture. The Docker Swarm is the guy which will going to orchestrate your entire container orchestration frameworks and everything, and also can take the Docker services and everything, right? You would like to, if you would like to, right, other than that, if you'd like to use some other mechanism, so you can also use the Kubernetes, which is going to also one of the platform which can be used to orchestrate your Kubernetes or your Docker containers as well. If you'd like to host the multiple containers and point to the one of the services, you can do it. You can also do the same thing using Docker Swarm as well, right? Yeah, that's it. I think that's it by my end for today. If anyone has any questions, please let me know. I will try to answer all the questions.
Sir, Python is also required for the DevOps.
Yeah, technically it is required. Like if you take an example, right? If you're working for a automation scripting, right? If you're working for AWS, there you are using the Lambda scripting. Lambdas, right? You are writing the Lambdas. If you are good with the something like a Java or those kind of things, you are okay to write. If the same thing that you have to write it, if you don't have any idea on uh, Java or any other platforms, the simplest programming language which I can call it as a Python. So if you know the Python, how to use the Boto3, how to use the if and how to write the if and else conditions. If you know read the documentation of Boto3 modules, you can write it easily, right? So if I required for DevOps point of view, I can say 70% of the situation you might need to use Python or some other programming language. It not need to be a Python. You need to be good familiar with some other programming as well.
Bash scripting is not sufficient.
Bash scriptings, it will help you a particular level of situations. If you go for beyond that one, right? So let's take an example. There might be a situation I have to use some automation scripting language. I can call it as a Ansible, right? So Ansible, which is written in the backend Python language. If there is some exception got occurred while you are running Python scripts, right? While some exception got occurring in your Python script, you might face a lot of issues to understand what happening exactly. That kind of situation, to understand what is the exception error, whether it's a issue related to my end or it's issue related to some other components, you have to understand the errors as well, right? So if you're trying to use the Ansible also, which is written in the Python language, they're going to use the YAML syntax to write all your syntax and everything. At least I can say like you have to know minimum to understand what happened exactly.
So in Python, we need to learn scripting, Python scripting,
Yeah, it is good to learn.
not programming. No, how many types are there in the Python?
There are
Python
different
programming
kinds,
is
like
also there, right?
there are the OOPS programming within the Python, right? There is a lot of there are the Flask frameworks, Django frameworks,
Yes,
all those kind of things are
which
there.
particular model we need to focus.
You no need
Which
to
particular model
know.
we need to focus on?
You no need to be good on with the Django frameworks or the Flask framework, all those things. You should be at least good with the. You should be good with the. I can say like a basic understanding how to write the classes, basic classes, how to write the if else condition, how to write the while loops and everything. You should be good. At least you should be good with those languages. At least those level of understanding should have to familiar.
Yeah, that is Python scripting. That's enough, right?
Yeah, yeah, yeah. That should be enough. Any other questions?
And what about Terraform, sir? We need to go with the Terraform, or else just Docker and Kubernetes is enough for DevOps.
So Terraform is again a complete different target, right? So when I say like if you want to do some kind of automation with respect to infrastructure, right? If you're working for the multi-cloud technologies such as AWS, Azure, or it may be some other platforms, Google Cloud. So you want to provision the infrastructure. So you can ask a question like AWS guys will support cloud formation templates, Azure guys support Azure templates, Google guys support the Google formation templates, right? So if you would like to work on each individual technology, you have to be familiar with all these kind of technologies, right? getting learned, like if you're working for that Google, you have to learn the Google templates. Instead of learning those kind of things, repeated work, if you're good with the Terraform, by using Terraform, you can manage all these kind of resources. It's not able to cloud platforms. You can also manage the Docker as well. You can manage the Docker build commands, building the images, and also deploying the images. And also, if you want to manage with the Kubernetes, you can also manage and provision the Kubernetes cluster using Terraform as well. So I can say, like, if you'd like to get into the market with the very, I can say, like, most of the 75% of organization, they are using Terraform.
Okay.
So I can say, like, you should be good learn my Terraform as well.
Hi, my name is Suresh. What sort of questions we can expect in interview? I mean, any mock questions? Can you tell us?
Yeah. Okay. Coming to mock questions, right? So they're going to ask one of the question about what is Docker image, what is Docker container. I mean, that is a default question they're going to ask. Right? Once that is done, what is difference between the add command and what is different add command and copy command? That is the one thing they're going to ask. And they're going to ask, like, how to avoid the multiple layers while you're building the Docker images. Right? That is a one kind of questions they're going to ask with respect to Docker. And the most important question they're going to ask, what is the difference between Docker entry point, Docker command, which is CMD, and a Docker run command? What is the difference between these three commands? So these are the basic questions. These are the questions they can ask. If other than this, if they're going to ask like a scenario based, right? They are going to ask a scenario based, like hey, I have an issue. Like, let's take an example here. So I have an application that is running on my local environment, which is fine. So I would like to promote the changes to multiple environments. So for this, I would like to use Docker as one of the source. I want to deploy using Docker. How can I issue this complete end-to-end CI/CD pipeline? Those kind of things, right? That is the one kind of question they're going to ask, right? I want to deploy. They're going to ask, like, they would like, sometimes some of the person they're trying to ask you confused, right? So I have the one of the Docker image. Can I deploy this Docker image into my ECS platform on AWS? They might ask, like, can I use this Docker image to deploy into the Kubernetes platform, or I may need to make any changes? These are the kind of questions they're going to ask you. Other than this, there's nothing you can expect beyond this one. But like there might be a situation they're going to ask you about the commands. What is the command to create a container? What is the command to build an image? And how to remove the existed containers? How to remove the images? Those kind of things. Or they're going to ask about how to validate the logs of your running containers, how to inspect about the information about your containers, those kind of things. So all these commands that I've shown today, and you will get the what if you went through all the options that I shown today. So you should be good to go for the interview as well with respect to Docker. Yep. Any other questions?
How to get the recordings?
Recordings you can get it from the Ramesh. You can answer the question on that one. I think he's posting on the YouTube as well. You might get it on the YouTube if you follow the Micronet YouTube channels, or you can get it if you try to subscribe the Micronet. You can, if you can follow, you can get it from the Facebook. They are also providing the links for the YouTube channels and everything. So if you have any feedback kind of things also about the sections, you can provide the feedback on any of these listed channels, Facebook, Meetups, on LinkedIn. Or if you're looking for the something interesting topics that you like, if I see like some of the person they ask the question about Terraform, if you would like to learn about the Terraform or some other platforms, you can also request the things. So Macronite will try to arrange sections on that one as well. So I would like to provide some of the links. If you can provide please fill the information on this one as, and you can also we also have the some of the prices for the links. So let me share you those links as well, or raffle links. Please try to fill those information. So let me post it here in the chart. So please fill this information. There is prizes for today's section and another link information if you'd like to provide the feedback, or please fill this information as well. Yep, any other questions on this one? If you'd like to know any other things. Yep, please post your feedback today for today's section on Facebook, meetup links, and the LinkedIn's that we provided here. Yeah, if anyone has any questions, please let me know. Okay, if there's no questions, thank you very much for joining that section today. Yeah, if you're looking for something new technologies, please send a request to Facebook or LinkedIn. So we will try to answer the sections as well.